Hi everyone, today we continue automating work with databases in LabVIEW. We are using graphic icons instead of traditional text-based code, very convenient and efficient. We are programming visually and LabVIEW does a lot of the heavy lifting for us. In the previous episode, we created the test station and the hidden subdiagram global variable. If you missed that video, you can find it here on the channel. On the test station, engineers will measure data and send us raw data for processing into the program database provider, which we are going to create now. In short, this is where our test station finally gets a friend to communicate with. I'm already in my IDE, Integrated Development Environment, which is LabVIEW. Our program will run continuously, so first we place a while loop on the block diagram. In structures we find while loop and stretch it across the entire block diagram. Why while loop I explained in the previous video. Same idea here. We add control for the stop button itself, and wait time from timing in milliseconds, a constant of 100 milliseconds. Think of while loop as the heartbeat. No heartbeat, no demo day, right? To start the process, we need to do the following operations. Open the database, see what tables exist in it, and check whether the table we need is already there. From database connectivity, select dbTools Open Connection and place it on the block diagram. If you want more details on a function, you can always go to Front Panel Show Context Help and hover over the function. It will show all inputs and outputs and description. Let's read it now. It opens the database connection using the connection information path and returns a connection reference. If prompt is set to true, LabVIEW displays a dialog box to set up the connection. Wire data to the connection information input to determine the polymorphic instance to use or manually select the instance. Pro tip, if your connection strings works on the first try, buy a lottery ticket. Now we need to set up connection information. For that, we create a string constant, add it here. I already have a prepared database connection link, so I just paste it, expand it, and connect it to connection information. Next, we need a constant, error in. We make it auto-sizing, arranged horizontally for convenience. This is where our error handling begins. In other words, this is where the safety net for the program starts. Now, we add a function from connectivity, database, utility, dbTools, list tables. We connect them together. Let's see what this function does. It lists the tables in the database identified by connection reference. So this function will show us what tables already exist. If the table isn't there, it's not a bug. It's product market fit for dbTools create table. Now we need to check whether the table we need was already created. We create another string constant and type the name of our table. Test station 1. This is just naming, but the naming tells the system what to look for. And yes, we always use underscore when naming the table. And now, if the table doesn't exist, we need to create, then insert data, and then close it. For that, we need a case structure. Case structure contains one or more subdiagrams or cases, exactly one of which executes when the structure executes. The value wired to the case selector determines which case to execute. To determine if the table exists or not, we use search 1D array, and the condition will be if the table exists, the index will be greater or equal. Yes. From comparison, select greater or equal to. Connect them and wire it into the case structure. Then we pull connections forward from open connection and list tables into the case structure as well. We connect the error in and list tables to the case structure. We connect the table name to the case structure, and we connect search 1D array with list tables and add the table name into the input element. So basically, this logic checks if our container already lives in the database or not. Now, if the table doesn't exist, on the false case, we need dbTools create table. Connect it, connect the table name, and now we need to define the table parameters, the columns. We create a constant outside the case structure because it's large, 6 columns. We give each column a name. First will be index ID, second current in milliamps, third voltage in volts, fourth resistance in ohms, and operator ID and timestamp ID. Now we add the maximum character size. We don't want to overload the database, and we already know approximately how many characters we need. So for index ID, we set around 20. Current, voltage, and resistance get 10 characters each. Operator gets 50, and timestamp ID gets 50. Now, invisible items enable horizontal scroll bar. collapse it so we only see 2 columns, but it's easy to view all if it's needed. Now, next, we need a for loop. Here, for loop collects all the column names in the table. Then we add unbundle by name, connect the columns and wire them to the case structure. Yes, we are looping over names because copy-paste is not a scaling strategy. After we created the table, we need to check again whether it was successfully created. So again, we use dbTools list tables from utility. We connect everything and wire the table name through the case structure. Now we need to show the list of tables on the front panel, so I go to NXG style, data containers, array, string, and name it tables. Expand it a bit, find tables on the block diagram, change it to indicator, and connect list tables to tables. Now we need indexing here, and another string constant for the index ID column. That will be needed later. That's everything on the false case. Now we move on to the true case. But let's save it all first. On the true case, that is, if the table already exists, we select the function dbTools select data from connectivity. It extracts, retrieves data from the table. Next, database variant to data. dbTools select data opens the table with specified parameters, and database variant to data shows everything inside. Connect the functions like this, clean up the wiring for better clarity. After all, a clean diagram makes troubleshooting painless. Now, to database variant, we need to connect an array constant. Go to array constant, string constant, resize it to 2D, connect it to database variant to data. It's not magic, it's just LabVIEW politely turning mystery boxes into arrays. Next, we need a combination that increases the index by 1 each time we get new data. So we need to convert string to number and back to string using the following functions: index array, decimal string to number, array max and min, increment +1, and number to decimal string. Now, database variant to data connects to index array. It doubled into a 2D array automatically. In disabled index column, we add constant 0. Now connect the functions all together, and from array max and min we take maximum value. We also need to connect table to dbTools select data function and to the columns. Pull the connection from the table name through and connect dbTools list table functions as well. If you need to remove broken wires, use the shortcut Ctrl+B. Ctrl+B is the engineer's version of "we'll fix it in post." Let's save it and move on. Oh yes, let's expand the while loop. We need more space. More space means easier wiring and fewer overlapping lines. Now let's add another for loop. In this loop, we will insert information into our table by using dbTools insert data function. Let's add this function to our programming flow. Now we need to change this connection to shift register and connect it in and out with the dbTools insert data function. Also, we need to replace the error in with shift register. Shift registers help carry and transport values from one iteration to the next. Let's connect the table name to our for loop, and on the connection out, let's choose tunnel mode, last value. Also, when connecting the column information to for loop, we need to disable indexing on the connection in and again choose tunnel mode, last value on the connection out. This ensures we only keep the most recent result instead of building a huge array. Connect dbTools insert data to the table name and to the column information. Now, on the front panel, we create a cluster, NXG style, data containers, cluster 6 elements. Add string control, expand it, copy until we have 6 of them and name them according to our columns names. Index ID, current in milliamps, voltage in volts, resistance in ohms, operator ID, and timestamp ID. Find the cluster on the block diagram, place it next to the function bundle by name, connect it, rotate it if needed. Cluster is our package of values and will be inserted into the row. Now, we don't need this cluster on the front panel, so we change it to constant and rotate horizontally. Move things around a bit to connect into dbTools insert data. A tidy layout keeps the logic understandable and neat. Let's connect index to the case structure, on both cases false and true. For current, voltage and resistance, we will need global variable. So we open the global variable created in the previous episode for our test station. I open the test station file, go to the block diagram and copy the global variable into this project. Now we duplicate it, move on aside, we will need it later. Change the global variables for current, resistance and voltage to read. Change on to read as well. We also need the function number to engineering string. Place it here and copy it 3 times. Add precision constants, set each to 2, connect current, voltage and resistance and also to the cluster. Engineers don't round, we communicate significance. For operator ID, add a string control. This will be operator ID. Find it on the block diagram and connect to the cluster. For timestamp ID, use getDateTime string, set it to false, we don't need seconds. Add concatenate strings, first the date, then a space, then the time. Connect into timestamp ID and save it. After inserting data, we again need to check whether the table was created and what kind of data is there. For that, we again use dbTools select data and database variant to data. Connect table and columns. Now we need a table on the front panel. Go to NXG style, list, table, and tree, table. Visible items, column headers, name it simply table. This is where incoming data from engineers will appear in real time, with all the column names we defined. Find this table on the block diagram, create property node, value, connected, change value to right, expand the property node and add column headers. Select property, column header strings. Now we also need array string constants for database variant to data, same as before. Expand it to 2D, connect to data type. Now connect data output to value and connect the column headers. Now we need to close the process. From connectivity database dbTools close connection. Connect and wire it to dbTools select data function. Now we enclose everything into a case structure. Expand the while loop. Make sure we do not grab the stop button and the wait in milliseconds. Expand the while loop on the other side too. Move on global variable out of the way. Go to structures and choose case structure. Enclose everything in it. Check the true case. Then finish wiring. Pull the error in through the while loop. Connect on to the case structure and on false case also pull the error in throughout. Long wiring, but everything connects properly. Check once more. Now we add an indicator to the iteration terminal and let's name it loop. Save it. And a quick note, I'm not explaining every tiny detail right now because I'm building logic blocks for a larger program made of many logical segments. We're building MES, Manufacturing Execution Software, or CRM, Customer Relationship Management. Every business has these systems in one form or another. Their function is to automate databases, organize data, and simplify, streamline working with information. As we build more logical blocks, I'll be explaining everything in more detail about what I do and why. So subscribe and stay with me to learn more in upcoming episodes. Now back to our project. The block diagram is ready, but the front panel, the face of the application looks, well, not great. So let's organize it. Operator, loop and all buttons, we move them into one place. Loop isn't in NXG style, so let's replace with NXG style and choose numeric indicator. Stop button also let's replace NXG style boolean stop button. Now we resize stop button in properties, we make it 40 by 110. Make the button text bold. Remove the label. Visible items, no label. The result is cleaner and more visually balanced. And overall UI polish matters because screenshots travel faster than specs. In operator ID, I type my name Lana K and set it as default. That operations make current value default, so if I'm the operator, it shows my name automatically. Now let's decorate the front panel. We'll look for frame. In the previous program I used recessed frame, so I'll use the same here. Although in future episodes we'll explore different styles. If you want to learn more about GUI design in different styles, stay with us for upcoming episodes. Now let's add some color. Go to Tools Palette, choose a color. Last time we used this one, no, too bright. Maybe this one. Yes, that one. Now I add the program name, database provider, DB provider, highlight the text, set size to 100 using Ctrl+, change the color, remove underline, for text color set white and save it. Now, just like last time, let's make the application look more realistic. Let's go to File, VI Properties, Category, Window Appearance. Not the same as VI name. We remove extension .vi. Customize, leave the title bar and Run button, allow user to close and minimize the window, OK and OK. Now the program behaves like a standalone application. Done. Let's see how it runs. The program starts, the while loop is running, and now let's test the previous program and this program together. Let's open the test station. Here's the test station and database provider. I'll minimize the block diagram and close context help. Run both programs now. Let's set records to 7. Click measure. The graph shows data. To learn how we build the test station, watch the previous video. Now I press send and immediately get the data into my database provider. List tables shows all tables created in this database, and here's the database. Here's the table we created today, test station 1. And the data was inserted into the table, index ID, current voltage, resistance, operator name, and timestamp ID, date and time. And if we measure again and send new data, we'll see new rows coming in, and index ID increases by 1. So 2 VIs talking, basically microservices for people who like wires. So we made it happen. Our programs run and communicate properly. We'll continue programming more, so stay with us. Thank you for joining LaPlanta Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to our channel to see upcoming episodes.